Hello everyone. Today we're going to be talking about the Introduction to Braking Distance section of our booklet. One thing I want to talk about a little bit is that when the province was designing this curriculum, they were making it with the intent of this being a curriculum for students who were entering their first year of driving. So this particular unit is very much focused on driving and some of the aspects that we have to consider in driving that have physics aspects, but they also have aspects that are connected to the actual action of driving. So when you're driving, you're driving to soccer practice when you notice a person crossing just ahead. How much distance will you need to stop and avoid hitting the pedestrian? How much time will it take to stop your car? In this lesson, you'll learn about the factors affecting the time and distance it takes you to bring your car to a complete stop. So let's think about those factors. So when you see someone driving, there are two different effects here. There's the actual physics of stopping, where you have to apply the force of the brakes, and that application of force to the force of braking force from the brakes and from the friction of the road, those two forces combined are going to have some effect on deaccelerating the car. But deacceleration is not instantaneous. It does have a time property. But on top of that, there's the actual driving action where you as the driver are seeing the person. Your body responds by pushing down on the brake. How long does that process take? Certainly for some, this process is longer than others. Um, so you've already learned that friction is the force that opposes motion. When applying the brakes in your car, there is friction created between the brake pads and the rotating wheels. This causes the car to slow down and eventually stop. From the time you apply the brakes to the time you come to a complete stop, the car continues to move. The distance you cover while braking is called the braking or stopping distance. Okay. Now, if I did this, well, keep talking. Uh, So the reaction time is a person's reaction time also has an impact on braking distance. Reaction time is the amount of time it takes for you to recognize a situation and react to it. For example, if you see a dog run out in front of your car, you process the information and decide that you need to immediately apply the brakes. It might take you 2 seconds to react to the dog on the street and apply the brakes. This would be your reaction time. Some people naturally have a quick reaction time, but there are some factors that will increase your reaction time and should be avoided when driving. These factors include alcohol, which is a depressant. Other drug use, of course, can interfere with your reaction time. Um, and of course, being sleepy. Maybe we should put some of these down. So other drug uses. And I'm sure that would have been a discussion point if we were in class, but I'll just have to take my word for it. There are also sleepiness or tiredness, right? Tired and sleepy drivers. That's why that's why truck drivers are required to take a break every certain number of a certain distance or a certain amount of time. They're not allowed to drive a certain number of hours. Um, what are some other factors I'm thinking about? I mean, there's certainly some factors like disabilities or disability or even age, right? I don't know if maybe that starts to count to uh, age can be a factor in the extreme cases, right? So sometimes these could be a factor. So that's certainly like my grandma's not the maybe not as comfortable as driving as she used to be because she does find that her reaction time isn't as fast as it used to be. So there is a really fun little reaction test you can do for yourself if you want. If you want to find someone to do this with, um, I will try to find a video of somebody doing this experiment at home and post it with it. But essentially, what you're going to do is you're going to take a ruler, place it in your hand. Here's my hand here. The ruler is you're going to hold on to the ruler at near the tip, make a note of what number this is. So what number? Maybe it's, so let's say that it's 0 centimeters. And then you can essentially you release it and release the hand, and how does it work? I think or no, maybe someone drops it for you and you catch it, something like that. Anyway, so as you drop the ruler, you catch it, and when your hand catches the ruler, it will the place that you catch it at. When we look at this number, we can tell, so let's say this is, 15 centimeters. Then we can estimate from the 15 centimeters and the 0 centimeters how far it dropped, and how we can use acceleration and things like that to calculate out exactly how much time has passed using just the numbers on the ruler. So I'll post a video about that to give you a better explanation about that. So how does this apply to braking distance? Well, even if you have a fast reaction time and are wide awake, sometimes your braking distance can be longer than you anticipate. There are factors that can influence stopping distance that are out of your control. When driving conditions are slippery, wet, or snow-covered, the friction is reduced, right? That's what we discussed in our last video, and the braking time will be increased. While you cannot control the road conditions, you must anticipate a longer braking distance and driving accordingly. This means slowing down, giving yourself plenty of room to stop. And there are lots of little tricks for this. Of course, when you're driving, you can note a marking, and you should be able to count to 3 or 4 before your car passes the same marking. Maybe it's 5 or 6. All sorts of things to keep your cars separated. And also notice that if you're going faster, which is not mentioned here, but when you go faster, it takes longer to brake as well. So the faster you go, the longer the braking time is, in addition to the reaction time. So that means that the faster you go, the larger the space should be between your cars. So there should be no tailgating on a highway, in an ideal world, because the cars take longer to brake when that happens. So if someone in the front of the car has a quick reaction speed of, sees something dart out from the road, or sees some debris on the road, they quickly hit their brakes. Then you following them, if you're following too closely, there's a risk that you'll crash into them, because you not only have to react faster because you're moving faster, but you also you'll have to apply brakes for longer to slow down because you're moving faster. Finally, there are factors that affect braking distance that have to do with the condition of your vehicle. So, are your brakes in good order? So, old brakes or damaged brake parts, those would all have impact on your braking. And then your tires. Do your tires have enough tread for you to give you the traction you need for braking? As the tire tread wears out, this also impacts that frictional factor and brings it away from 0. Okay, so there are some questions here to think about, and I think what I'll do is I will repost these questions as an interactive on our classroom. So that's where you'll see them. So please check those out. And with that, we'll let you go, and we'll talk to you in the next video, where we'll actually do some math related to this braking.